ECS aggregation switch has 48 SFP28 parts and 6 QSFP28 parts. So in this video, I'm going to use multiple types of cables ranging from 10 gigabit to 100 gigabit. They are fiber or DAC cables or even breakout cables. So in this video, I'm going to test their connectivity by using this ECS aggregation switch. Especially, I'm interested in whether this switch support breakout cables. Let me first SSH into the switch. As explained in my previous video, this switch doesn't use the traditional Ubiquiti CLI. Instead, it uses Sonic. So let me show the platform information. You can see this switch using Marvell ASIC, and this is the platform information. So if we go to the device folder for Sonic, you can see the installation comes with all sorts of devices, not just Marvell, not just for this switch. It comes with the x86 version and ARM version. As you can see in the previous command written, this switch is based on x88 platform. So let me cd to this particular folder. In fact, we are missing a very crucial file for the platform. So later we will discuss that. And another command I want to show you is about EEPROM information. We will use it multiple times in this video. So let me pick port 16 as an example. So the internal name for port 16 is Ethernet 15. What I'm saying is I want to see the interface transceiver EEPROM information for this particular part. Okay, very useful information about the internal technical attributes. Okay, just several general commands. Let's get started. I'm going to start with 10 gigabit connections. See in the UniFi network controller, these three parts, 9, 10, and 16, they are showing this blue color. They have 10 gigabit speed. In the SSH, let me run the show interface status Sonic command. Then for port 9, the interface name is Ethernet 8. So you can see for this particular line, the speed is 10 gigabit. Even though this part is SFP28, it supports maximally 25 gigabit without any manual setting. It's automatically negotiated to be 10 gigabit, which is good. By default, this UniFi switch configured every single part to trunk part. In most use cases, we want a part to be a trunk part by default. Unlike some other 100 gigabit switch, by default, each part support L3 VLAN. So here it will show routed. So it's good. Ubiquiti automatically configure them to be trunk. Okay. Then operational status is up because it's connected. It's showing a blue color here. See the type? This column doesn't have very detailed information. From this UI or from this command output, you still don't know what's the type of the cable. From the command line, you can run the interface transceiver EEPROM command. This time, let me show Ethernet 8. Okay. The connector is LC, which stands for loosened connector. And here we see the standard 10G base SR. SR stands for short range. It is a standard for 10 gigabit Ethernet that uses short range fiber optics to transmit data. And you can see the maximum length is 30 meters. Because I purchased this optics module from Ubiquiti, here you can see the vendor name is Ubiquiti Network. So this is the module information. Then from the color of the fiber cable, the jacket, you can tell it's aqua. Normally, that means it's OM3 multi-mode and it's for short range uses. And I plug it into a 10 gigabit module. That's why for the port 9, I get 10 gigabit speed. Okay, let's move on to port 10. I plug in a DAC cable. As you can see, the other end is a UniFi 10 gigabit switch. From the SSH, let me run the EEPROM command for Ethernet 9, which is port 10. So the connector is copper pigtail. So when it comes to standard, it simply says it's SFP plus cable technology, passive cable, and the vendor name, interestingly, it says OEM. It doesn't say what's the exact vendor, but here it does tell you the vendor OUI. You can use OUI lookup tool on the internet, for example this Wireshark one. So let me type in the vendor OUI. It says CommScope Incorporation. I purchased this DAC cable from Amazon, so it's just some cheap compatible third-party DAC cable. It works fine. Okay, move on to the third 10 gigabit connection, port 16. I plugged a SFP Plus to RJ45 module into port 16, and then I plug in a Ethernet cable connected with a Mac machine. Here from the command line for Ethernet 15, you can see the EEPROM information to understand what's inside the module. It's from the same vendor. The vendor OUI is the same as previous one. This time it does have vendor name QSFP tag, another cheap conversion module I purchased from Amazon, and you can see the specification is the same as previous one, passive cable, even though this one is a SFP Plus to RJ45 conversion module. And again, the connector is the same copper pigtail. Okay, now we are done with the 3 simple 10 gigabit connections. Move on to 25 gigabit. For these 3 parts, 23, 24, and 28, I have 3 different connectors. As you can see, 2 of them are showing 25 gigabit connection, but this part 24 is only 10 gigabit. We will see what happened. So let's start from part 23. I use a cheap SFP28 transceiver purchased from Amazon, so it's compatible with Mellanox. You can see the standard it supports is 25G base SR. SR stands for short range. And in the details, you can see if you use OM3 fiber up to 70 meters, if OM4 is 100 meters. Good enough for my use case. And for the port 23, I connected with a UniFi switch using a aqua color fiber. Color aqua means it's OM3 fiber type. It's multi-mode for short range usage. That's the correct choice for this transceiver. So from SSH, if I run this EEPROM command for Ethernet 22, which is port 23, you can see the EEPROM information. Yes, it supports 25G base SR, and it shows the vendor is Mellanox, even though I know it's not really from Mellanox, it's just compatible with Mellanox. This is the part number from the vendor. For this particular part, everything works fine. But let's see for port 24. I use the exact same transceiver. We can validate it from SSH. So let me show the EEPROM information for Ethernet 23, which is port 24. This is the exact same model of transceiver. But for this case, as you can see from the video, the cable jacket color is violet, which means it's OM4. It's supposed to be even better. However, the other end of the fiber is from a third-party 100 gigabit switch, and I use a breakout connection. If I set each breakout cable to 25 GB connection, this part won't even show connected. Only if I set it to 10 GB, this part will be showing as blue as active. I'm not sure what's the exact reason, either because of the compatibility between my transceiver and the fiber. I doubt that's the case, or it's because something's wrong in the other end of the connection, which is in the third-party 100 gigabit switch part. Maybe some compatibility issue there when I set up the breakout. But anyway, I don't think that's the issue for this UniFi switch. Okay, so move on to the port 28. I use a Ubiquiti DAC cable for SFP28. So we can validate the EEPROM information, port 28, which is Ethernet 27. You can see the vendor is Ubiquiti. This is the model. It's a DAC cable, 1 meter long. And this is the extended specification. It supports 25 gigabit. Okay, so this one works perfectly. I use it to connect to the router EFG gateway. Okay, so for 25 gigabit, we are good. Then let's move on to 40 gigabit and 100 gigabit. For the 6 100 gigabit parts, the QSFP28 parts, I have plugged in 6 different DAC cables. 4 of them have the QSFP Plus connectors. They support 40 gigabit. And 2 of them have the QSFP28 connectors, so they support 100 gigabit. However, from UniFi network controller, you can see only the 2 100 gigabit parts. They are showing dark blue color, which means they are operating in 100 gigabit, or other 4 parts, they are showing not connected. So there's something wrong with the 40 gigabit connections. In the SSH window, let me run show interface status. You can see for the 6 parts, they all have the cables plugged in. They are all showing the correct connector information. For example, for the 4 QSFP Plus parts, they are for the green cable for the 40 gigabit cables. So let me pick one example. Let's say the Ethernet 48. You can see the vendor is Mellanox and it's QSFP Plus. All the 4 cables are the same. They work perfectly fine in 2 of my other switches. One MikroTik switch, the other one third-party 100 gigabit switch. The cables are perfectly fine, but they don't work in this UniFi switch. The only reason I can think of is the compatibility issue. Maybe I'm wrong, but that's the only thing I can think of. By the way, here the type is already showing up as QSFP+. Apparently, I don't really need to worry about the link speed negotiation, right? But just to be sure, I did try to set the part to 40 gigabit manually. It didn't help. Because I only have this for 40 gigabit cables, all of them don't work. I have no other 40 gigabit cables to test. As the last try, I connect the exact same 40 gigabit cable between 2 ECS-Aggregation switches. All of a sudden, I see the LED light is on. That means it's connected. However, if I go to the port manager, you can see, yes, it's connected, but see the color is dark blue, which means it's using 100 gigabit. My theory is because it's such a short cable and the 2 UniFi switches negotiate the speed to be higher than its specification. That's understandable. But when I use it to connect to other devices which only support 40 gigabit, it doesn't work for unknown reason. Okay? And then for these 2 100 gigabit cables, so if I show you the EEPROM information, for example, Ethernet 53, so you can see the vendor is also Mellanox. However, if you compare this working 100 gigabit EEPROM with the non-working 40 gigabit EEPROM, you can see here the extended specification compliance code. For the 40 gigabit, it doesn't specify anything, and for the 100 gigabit, it did specify 2 compatible modes. So I'm not sure whether this missing information caused the 40 gigabit cable issue for me. But this 100 gigabit cable works perfectly fine. It's also made by Mellanox. One last thing to mention about the 100 gigabit connection is about FEC. Let me run the command show interface status. You can see for these 2 100 gigabit connections, for the column FEC, they are both showing RS. So FEC stands for forward error correction. It's a method used to detect and correct bit errors in high-speed data transmission. For example, this 100 gigabit Ethernet connection. The value RS stands for Reed-Solomon. It's a special type of FEC. In my another 100 gigabit third-party switch, for the 100 gigabit connection, I need to manually run the Sonic CLI command to set the port, the FEC method, to RS. Otherwise, the connection won't work. But for this UniFi switch, the switch automatically determines, okay, for this cable, the FEC should be RS. So it automatically set it for me, which is perfect. Okay, move on. So far we have covered the typical use cases for all the different types of cables. Most of my existing cables work fine. And as the very last part of the video, let me talk about Breakout. I have three types of cables that support Breakout. Basically, for Y end, it's a regular QSFP Plus or QSFP28 part, which support 40 gigabit or 100 gigabit. The other end are for either SFP Plus part or QSFP ports, which means they are for 10 gigabit or 25 gigabits. So the purpose for this type of cable is you have one part on your high-speed switch, for example, this ECS-Aggregation, and at the other end, you can connect 4 different separate devices. That's what Breakout means. So this functionality is very handy. I like it very much. I use it extensively on my other switch. So right after receiving this UniFi switch, that's the first thing I want to try to see whether the Breakout function works or not. So let me use the port 52 as example. Click on it. In the port settings, I don't see anything about Breakout. So under link speed, these are the only 3 options I have. It's not supported on the UI for sure. However, I do know there's Sonic command to set a interface to support Breakout. So then I go to the SSH. Let me run this Sonic command. Config interface Breakout Ethernet 52, and the exact way to break it out is for 25 GB connections, and in the brackets is a alternative option. I can also break it out to for 10 gigabit connections. Okay, then run it. Okay, continue. Okay, this is a roadblocker. It says Breakout feature is not available without platform JSON file. So remember in the very beginning of the video, I show you a Sonic device folder. Let me go to that again. Okay, go to our platform, which is x86, which is this particular device. So under this folder, you can see there's no platform.json file. That's what this red arrow is complaining about. Apparently, either this device really doesn't support Breakout, which I seriously doubt, or for whatever reason, Ubiquiti doesn't include this platform JSON file, so that the Sonic operating system doesn't know whether or how to break out a specific part. If I search platform JSON file, you can see there are a lot of platform JSON files for all sorts of different platforms. However, for our platform, for this particular ECS aggregation, it's simply not included. It's a very disappointing finding. Once I realized this error, I opened a case with Ubiquiti. After several days, I got confirmation from the Ubiquiti supports. I was told this switch doesn't support Breakout. Of course, they won't tell me whether in the future Breakout will be supported or not. So that's the official answer from Ubiquiti. But I don't want to give up, so I tried to manually edit the config file. So you may know there is a config db file. That's the result of the Sonic command. Let me show you. See, it's here under etc Sonic. The interface 52, we just tried to break out. The current active setting, it uses 4 lanes. Each lane support 25 gigabit. So that's why in total this Ethernet 52 interface support 100 gigabit, right? But I did try to manually break it out by configuring 4 ports. Each one only use one distinct lane here, and for each one I set it to 25 gigabit. And then of course I use Sonic command line to reload the configuration. However, the end result is it doesn't work because the configuration file is invalid because Sonic doesn't know the platform.json. Okay, that's really a bummer. So I won't show you my manual steps in this video because it didn't work. Yeah, that's it. Maybe very disappointing news for you if you want to use Breakout. For now, it's not supported. Okay, this is the end of the video. Thanks for watching.